Hello everyone! This video is the last in my series explaining AIME problems. In this video, I'll be talking about problems with the geometry of solids and the ways that they can be solved. I encourage you to pause throughout the video and try to solve the problems. There are some prerequisites that you should know before this video. You should know most of the basics of vectors and what parametrization is. You should also know most of the formulas for volumes of figures, such as the volume of a cone, pyramid, prism, etc. Finally, you should know all of the geometry that was covered in previous videos. Let's start with the problem that involves volume. A block of cheese in the shape of a rectangular solid measures 10 centimeters by 13 centimeters by 14 centimeters. 10 slices are cut from the cheese. Each slice has a width of 1 centimeter and is cut parallel to one face of the cheese. The individual slices are not necessarily parallel to each other. What is the maximum possible volume in cubic centimeters of the remaining block of cheese after 10 slices have been cut off? So after drawing the diagram of the cheese, which is 10 centimeters by 13 centimeters by 14 centimeters, nothing really pops out. But if we think about it, whenever we cut a slice, we reduce one side by 1 centimeter, and the other two sides stay the same. And we want to reduce the least volume per cut. To do that, we just have to reduce the least volume, so the least area of a face. So for example, with 10, 13, 14, we have to reduce 10 times 13, since that's the least possible volume that we can reduce. So we keep 10 and 13 the same, and we reduce 14 by 1, getting 10, 13, 13. Then for this, the smallest possible volume, the smallest possible volume that we get is 10 times 13 times 1. So we keep 10 times 13 and we reduce the other 13. And we get 10, 12, 13. Continuing this, for 10 slices, we'll get our answer. And we end up at 999, which is the largest volume that we can still have. So our final answer will be 9 cubed, or 729. Here is another problem about volume. Cube ABCDEFGH, labeled as shown below, has edge length 1 and is cut by a plane passing through vertex D and the midpoints M and N of line segments AB and CG respectively. The plane divides the cube into two solids. The volume of the larger of the two solids can be written in the form P by Q, where P and Q are relatively prime positive integers. Find P plus Q. So to do this, we'll use coordinates, but we don't really know how to use 3D coordinates too much. So we need to learn how to use 3D coordinates to represent a plane and a line. The equation of a plane in 3D space is ax plus by plus cz equals d, and the coefficients a, b, c, and d can be found with 3 points on the plane. And the equation of a line in 3D space, with vectors and parametrization, is, in vector form, xi plus yj plus zk equals ui plus vj plus wk plus ati plus btj plus ctk, where uvw is a point on the line, abc is the direction of the line, and t is any real number. And the parametric form is x is equal to u plus at, y is equal to v plus bt, and z is equal to w plus ct. Coming back to the problem, we see that we can solve it pretty easily with coordinate geometry. First, let's set d equal to 0, 0, 0, the point 0, 0, 0. Then, we need to find the equation of the plane DMN and the equation of the line BF and find the intersection. So we know that the point M, and let's say DA is the x-axis, DC is the y-axis, and DH is the z-axis, then M is 1, comma half, comma 0, n is 0, comma 1, comma half, and b is 1, comma 1, comma 0. Then, for the equation of a plane, we have that ax plus by plus cz equals d. Plugging in 0 for x, y, and z, because we need the point D to be in the plane, we get that D equals 0. Now, for the other 2 points, we have that a plus half b equals 0, and b plus half c is equal to 0. So we get that c is equal to 4a, and b is equal to negative 2a. Plugging these back into the equation for the plane, we get that ax minus 2ay plus 4az is equal to 0. And canceling the a, we get that x minus 2y plus 4z equals 0. Now, for the line, we know that x is equal to 1, y is equal to 1, and z can be any value, let's say t. Because the line is a vertical line, and it stays over the point 1, 1, 0, or below. Now, we have to plug in these values to the plane to get the intersection, which we get as 1 minus 2 plus 4t equals 0, where t is equal to 1/4. So 1, 1, 1/4. Now, let's redraw the diagram. Here, we have dm, dn, cn, cb, and bx, let's say, mx, and xn. And after we plug in the values, which is half, 1, 1, 1/4, half, we see that this is a frustum, which is just a pyramid with the top cut off. And the part that is cut off, the base of that is parallel to the base of the pyramid. And we can extend this way to get a pyramid. So, what is the actual volume of the frustum? Well, we need to find the volume of the pyramid minus the volume of the small pyramid. And that we get as half times 1 over 2 times 2 over 3 minus half times 1/4 over 2 times 1 over 3, which equals half minus 1/16 over 3, which is 7 over 48. And that's the volume of the frustum. But we need the volume of the stuff other than the frustum, since 7 over 48 is less than half. So we need to subtract this from 1, and we get 41 over 48. So our answer is 41 plus 48, or 89. Now let's do a problem in which we have to convert from 3D to 2D. A right circular cone has radius r and height h. The cone lies on its side on a flat table. As the cone rolls on the surface of the table without slipping, the point where the cone's base meets the table traces a circular arc centered at the point where the vertex touches the table. The cone first returns to its original position on the flat table after making 17 complete rotations. The value of h by r can be written in the form m root n, where m and n are positive integers and n is not divisible by the square of any prime. Find m plus n. So to start this, let's draw a diagram. This is the cone on its side, and this is its circular base. And this circular base rotates 17 times before it gets back to its original position. But what do we actually want in this diagram? We want the circle that is drawn out. And that is just a circle with radius square root of r squared plus h squared. Because in a cone, we can treat it as a triangle with this is r, this h, so the slant height is r squared plus h squared. And the radius of the small base is just r. And we know that 17 times 2 pi r is equal to 2 pi square root of r squared plus h squared, because the small circle also traces out the exact same path. So, canceling the 2 pi's and squaring, we get that 289 r squared is equal to r squared plus h squared, and 288 r squared is equal to h squared. And dividing both sides by r squared, we get that h squared by r squared is equal to 288, or h by r is equal to 12 root 2. And we want m plus n, which in this case is 12 plus 2 or 14, which is our answer. Here's another problem where we have to convert from 3D to 2D. Two long cylindrical tubes of the same length but different diameters lie parallel to each other on a flat surface. The larger tube has radius 72 and rolls along the flat surface toward the smaller tube, which has radius 24. It rolls over the smaller tube and continues rolling along the flat surface until it comes to rest on the same point of its circumference as it started, having made one complete revolution. If the smaller tube never moves and the rolling occurs with no slipping, the larger tube ends up a distance x from where it starts. The distance x can be expressed in the form a pi plus b square root of c, where a, b, and c are integers, and c is not divisible by the square of any prime. Find a plus b plus c. To start, let's draw a diagram. Let's say that this is the large tube, and this is the small tube. Then, the large tube makes it about this far, then it rolls over the small tube, and it continues rolling till it reaches the same point on its circumference. So, we know that this length exactly will be 96 since it's 72 plus 24. We also know that this is 24 and this is 72. So the difference for this right triangle is 48. And this turns out to be a 30, 60, 90 triangle. So this angle is 30 degrees, which we'll use in the next slide. To solve this problem, we also need to know that for rolling occurring without slipping, the path traveled by the center of the circle has the same length as the radius times the angle turned in radians, or has the same length, in this case, as a circumference. So we know that this whole length will be 2 pi times 72, or 144 pi. But we need to subtract off this length, which is, since this is 120 degrees, 96 times 2 pi over 3, which is 64 pi. And we get that the pi value is 80 pi. But we need to find the value which has the root as well. And we get that in this horizontal distance, which with the trig formulas is 48 root 3 plus 48 root 3, or 96 root 3. So our answer will be from 80 pi plus 96 root 3. And our final answer is 96 plus 3 plus 80, or 179. Let's end with a problem that involves conversion. A square piece of paper has sides of length 100. From each corner, a wedge is cut in the following manner. At each corner, the two cuts for the wedge each start at a distance square root of 17 from the center, and they meet up on the diagonal at an angle of 60 degrees. See the figure below. The paper is then folded up along the lines joining the vertices of adjacent cuts. When the two edges of a cut meet, they are taped together. The result is a paper tray whose sides are not at right angles to the base. The height of the tray, that is the perpendicular distance between the plane of the base and the plane formed by the upped edges, can be written in the form the nth root of m, where m and n are positive integers. M is less than 1000, and m is not divisible by the nth power of any prime. Find m plus n. To start, let's take a screenshot of the paper tray from the top. It will just be two squares. And we'll know the difference between the lengths of the squares, so we'll know this, because the difference will just be this value. And because of this, and since this is at 45 degrees because of symmetry, we'll know this length as well. Now let's draw a triangle. Let's say this length becomes that. This is the height from the ground. And this length, since this is taped together with this side, becomes the diagonal, which is this length. And we'll know both this side and this side. So we can just find h from there. Let's do that on the next slide. By symmetry, we have that this angle is 45 degrees. And so this angle is 75 degrees. Now, let's say this value is x, this value is y, this value is a, this value is b. Then, by the law of sines, we have that square root of 17 by sine 30 is equal to x by sine 75, which is root 6 plus root 2 over 4, which you can find by the trig angle addition formula. And sine 30 is just 1/2, so this becomes 2 root 17, where x is equal to root 6 plus root 2 over 2 times root 17. But we want x by root 2 because we want y. So y is equal to root 51 plus root 17 over 2. Now, we also want b, and we can get that by the law of sines again. We get that b by sine 45 is equal to 2 root 17, and sine 45 is root 2 by 2, so this becomes root 2, or b is equal to root 34. Now, clearing some space, we also want a, and a equals the square root of b squared minus y squared, which is equal to the square root of 34 minus 68 plus 34 root 3 over 4, or 68 minus 34 root 3 over 4, and the square root of that, which is also equal to the square root of 34 minus 17 root 3 over 2. But what value do we actually want? We don't want a. If you recall from the previous diagram, if this was a, that's the difference, then we want a root 2. And so a root 2 is, after clearing some space again, the square root of 34 minus 17 root 3. And our final answer is h, which is equal to square root of b squared minus a squared, which is the square root of 17 root 3. And putting it in the way that they want it, this equals the fourth root of 867. And 867 plus 4 is just 871, which is our answer. Thank you for listening. Please like and subscribe, and remember to click the bell icon for more updates.